Okay, if you've been watching the tech space lately, you know the sheer volume of updates is just overwhelming. So let's filter out the noise. In today's Explainer, we're going to zero in on the two massive forces that are truly reshaping our world in 2026. I like to call them the brain and the brawn. We're talking about the explosive rise of autonomous software systems and the absolutely staggering physical AI hardware we need just to run them. Because, let's face it, for the past few years, we've basically treated AI like this incredibly smart oracle, right? You type a prompt, you get an answer. Well, to put it bluntly, the era of treating AI as just a chatbot, it's over. We are literally building continent-sized computers right now, and we're handing the software the keys to act completely independently. We've officially shifted from just answering questions to executing some incredibly complex actions.
So here's how we're breaking it down today. First, we'll look at scaling the AI brawn. Then we'll tackle the hardware bottleneck. After that, the rise of autonomous agents, how AI is entering physical reality, and finally, governing the autonomous brain. All right, let's jump straight into Section 1, Scaling the AI brawn.
Check this out. OpenAI has just secured a mind-blowing 10 gigawatts of U.S. compute capacity for their Stargate infrastructure expansion. Now, to put that massive number into perspective, 10 gigawatts is roughly the power output of 10 standard nuclear reactors. And all of that is going entirely to computing clusters. By smashing their 2029 target years ahead of schedule, they're completely rewriting the timeline for advanced intelligence. The sheer amount of electricity, cooling, and physical land required for this is fundamentally transforming our global energy grids.
And you know, this scale is expanding globally too. But the driving force isn't just commercial anymore, it's geopolitical. Over in Europe, a transatlantic consortium just announced a €50 billion Pantheon AI hyperscale campus being built in Croatia. The real goal here? Establishing sovereign AI autonomy. Nations are quickly realizing that relying heavily on American or Chinese computing infrastructure is a huge strategic vulnerability. So governments are now treating AI data centers the exact same way they treat critical national defense infrastructure. Now, on the hardware coordination side of things, Google's new Virgo network is linking 134,000 individual chips into a single unified compute domain. I mean, just imagine the sheer optical bandwidth and networking precision you need to perfectly coordinate processing across over 100,000 accelerators without even a millisecond of latency. It's wild. This isn't just a big computer anymore. It's the mega-scale foundation absolutely required to train the next generation of trillion-parameter multimodal models. But of course, all that power brings us to Section 2, the hardware and energy bottleneck. We're actually in the middle of a massive paradox in the tech industry right now. On a micro level, hardware efficiency is just skyrocketing. Google's new TPU-8i chip targets highly cost-efficient inference for these agentic workflows, and it actually delivers an 80% performance per dollar improvement over previous generations. But on a macro level, this explosive overall growth is completely overwhelming the global grid. This astounding AI infrastructure demand is driving up natural gas power plant construction costs, extending project timelines by years, and pushing global silicon manufacturers like Samsung to their absolute limits. So the individual chips are getting significantly cheaper, but powering the collective aggregate, that is heavily straining the global economy. To fight these soaring energy constraints, the industry is literally having to invent new science. Enter Energizer. This is a breakthrough technique developed by MIT engineers, and it's pretty amazing. It accurately predicts an AI workload's exact power consumption on specific processors before the workload even runs. By forecasting and optimizing energy efficiency prior to deployment, operators can avoid massive energy waste during trial runs, which can potentially save billions in utility costs. The focus has really shifted from just making models smarter to making sure they don't blow out the power grid. Which leads us perfectly into Section 3, the rise of autonomous agents. So because of all this new hardware, we are now seeing software step out of the text box and onto the desktop. Systems like OpenAI's Codex and Standard Intelligence's new computer use models aren't just relying on back-end integrations anymore. They are actually viewing graphical interfaces, navigating complex operating systems, and completing multi-step workflows directly. They bypass APIs entirely to operate laptops exactly like a human user would. They process the pixels on the screen, they click, they drag, they type. They're navigating our digital environments natively. And let me be clear, these aren't just lab experiments anymore. The business world is heavily adopting them today. Canva, for example, has deployed AI agents that are entirely replacing marketing interns to autonomously generate graphics, draft copy, and schedule multi-platform campaigns.
And to facilitate this whole new machine economy, Stripe has launched Link, a digital wallet that lets autonomous AI systems spend money and conduct financial transactions completely independently. Meanwhile, Anthropic's Claude Opus 4.7 is out there right now, autonomously hunting down and solving 87% of software bugs for development teams. Software is officially doing the work of humans.
Let's move on to Section 4 and see how this all translates when AI enters physical reality. Because the physical manifestation of these AI brains is already here. With platforms like NVIDIA's Cosmos hitting 2 million downloads, developers are super empowered right now to build physics-aware AI. We are seeing humanoid robots successfully taking over repetitive, labor-intensive physical duties, like at airport baggage claims. They rely on advanced computer vision and complex manipulation systems to instantly identify, lift, and maneuver heavy luggage on the fly. The cognitive intelligence that was previously locked in the cloud is literally physically walking among us now.
Globally, though, the reception to this physical deployment varies wildly, and it highlights a deep geopolitical divide. In the United States, the Pentagon is leaning all the way in. They're signing classified AI integration deals with 7 tech giants, including Microsoft, Google, and OpenAI, to rapidly bring autonomous systems to defense domains. Conversely, Chinese regulators have completely halted all new robotaxi licenses so they can conduct comprehensive nationwide safety reviews of autonomous vehicle AI systems. We are basically watching a real-time, high-stakes global debate on exactly how fast life-critical autonomous technology should be deployed into the wild. Which brings up some huge questions, naturally leading us to our final section, governing the autonomous brain. Listen to this metric from the latest OutSystems report for 2026, because it's pretty alarming. 96% of enterprises run ungoverned AI agents. Wow. So while commercial adoption is almost universal, only 12% of companies have actual governance frameworks in place. This reveals a massive, deeply dangerous gap between companies that are eager to deploy autonomous agents for immediate productivity gains and companies that actually understand or control what those agents are doing behind the scenes. And we are seeing the severe, real-world consequences of this ungoverned landscape right now. Recently, an autonomous coding assistant powered by Claude mistakenly wiped out an entire corporate database. And yeah, that included all the redundant backups, in exactly 9 seconds. 9 seconds to erase a company's core operational data. When systems execute commands, click and type at the raw speed of compute, errors happen at a scale and velocity that human beings simply cannot intercept in real time. To prevent immediate existential disasters like that database deletion, organizations are scrambling to build rigid, foolproof guardrails. OpenAI, for example, recently instituted what they call Goblin rules. These are strict internal safety protocols for their Codex system, and they establish unchangeable, hard limits on what an autonomous coding AI can modify, execute, or delete without explicit, verified human approval. The enterprise industry is quickly realizing that sandbox testing and hard-coded kill switches aren't just nice-to-have features anymore, they are absolutely critical to corporate survival. And as history shows us time and time again, if technology companies don't self-regulate, governments absolutely will. European Union negotiators have just cemented strict, mandatory AI Act compliance deadlines. Phase 1 kicks in by December 2027, and by August 2028, uncompromising compliance for high-risk autonomous applications becomes mandatory law. The financial penalties for failing these audits are just massive. If businesses want to continue operating these agents in a European market, their compliance preparations have to start today, not tomorrow. So I want to leave you with this final thought for today's explainer. We are committing billions of dollars, gigawatts of power, and millions of silicon chips to build the physical brawn of the future. The infrastructure is scaling beautifully, and those hardware bottlenecks are slowly being solved. But when we look at the deleted databases, the massive governance gaps, and the urgent scramble for regulations, have we truly prepared ourselves for the autonomous brains that will be operating it? Thanks for joining me today, and keep learning.